Hello class, welcome to Unit 7. Today we're going to look at Video 1, which is Properties of Exponents and Scientific Notation. Your first learning target is that you can use property of exponents to multiply and divide monomials. Properties of exponents are really important. You'll see them a lot on the ACT as well as in upcoming math classes that you will take. So you want to make sure you have a solid foundation on the properties of exponents. You can also use expressions written in scientific notation. Scientific notation is something that does come up on the ACT as well. So you want to make sure that you feel comfortable using scientific notation and how to simplify scientific notation. So we're going to go to properties of exponents. To simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. Okay, so we want to make sure we have them simplified. We don't have parentheses and we don't have negative exponents. Also, you should see each variable, written only one time. Okay, so you can fill in the blank on your sheet. So to simplify all the way, we have no parentheses and no negative exponents. Also, you'll only see each variable only one time. Okay, so we're going to be simplifying today. Some rules. If you have the product of powers property, okay, that means you are multiplying, and when you multiply, you add their exponents. Okay, so here is an example. If I have x to the second times x to the third times x to the fourth, I would have x to the 2 plus 3 plus 4, which is really x to the ninth. My other example here is if I have m times m to the second. This is really m to the first. So 1 plus 2 is 3. Okay, so remember when you multiply, which is product, when you multiply, you add exponents. So multiply, they call it the product of powers. The other one is the power of powers. Okay, so you have an exponent raised to another exponent. The way you handle that situation is you take and multiply those exponents. So when you have an exponent to an exponent, you multiply. So if I have y to the second to the fourth, I would have y to the 2 times 4, which is y to the 8th. The next one, there is more than one piece here, so each thing needs to be taken to the third power. So it's really 4 to the third, x to the 2 times 3 is 6, and this is y to the first, so 3 times 1 is 3, so y to the third. Then I would simplify a little bit further. 4 to the third is really 4 times 4 times 4. You can also type it in on your calculator, which gives you 64, x to the 6th, y to the third. Okay. One thing I do want to point out, notice how everything in here is being multiplied. If we had 4x squared plus y to the power, you cannot distribute the way we did there. This is all being multiplied, this is being added. So since this is being added, you'd have to solve it like this. And from here, you would need to FOIL. So just notice the difference. If it's all being multiplied, I can give each value in there the power. Here, though, if it's addition or subtraction, you need to FOIL. Very different, and a lot of people make a mistake with that one. So just notice the difference between the two things. The next rule is our quotient of powers. Okay, so quotient means division. The way you handle that is you subtract. So when you're dividing monomials, you subtract their exponents. So here, it would be m to the 5 minus 11, which gives you m to the negative 6. Well, part of our simplifying, I said, well, you really can't have a negative exponent. So what you need to do is put it in the opposite part of the fraction. So if it's in the numerator, move it to the denominator, make it positive. So it's really 1 over m to the positive 6. Another thing that I recommend, that got all carried away on me. Another thing that I recommend is always bring the smaller exponent to the larger exponent. So here's my smaller, bring it to it and subtract. So it'd be 1 over m to the 11 minus 5, which gives me my 1 over 6, m to the 6th. Okay, so always bring the smaller to the larger. So looking at this example, my larger is here, so I'm bringing it up. So it's a to the 7 minus 3, which gives me a to the 4th. When you think about it that way, you always keep your exponent positive. Negative exponents, exactly like I was just talking about. You cannot leave any negative exponents in your final answer. So to fix it, move it to the inverse side of the fraction and make the exponent positive. Okay, so here is our first example. We have 3a to the negative fifth. One thing I want to point out, this is 3 to the first, which is positive. So my 3 will stay in the numerator. This is negative, so that goes to the denominator. So I would have 3 over a to the fifth. 2, that's really to the first power. And then this is negative, so I'm going to take this and move it up. So I would have 2x to the third. Okay. Another rule, 0 exponent. Anything to the 0 power is always 1. Excuse me. So make sure we do that. So they have this first example, it's all of this being raised to the 0 power. So since it's all being raised to the 0 power, it's going to equal 1. Here though, this is really 5 times x to 0. So only this piece is being raised to 0. So it's 5 times 1, which is 5. So there it is simplified. But remember, anything to the 0 power is 1. So we have some problems here we need to simplify. So remember, you cannot leave negative exponents in your final answer. And to get rid of them, you change it where they are on the fraction. Okay, so it says simplify each expression, write your answers with only positive exponents. It also cannot have any parentheses. And you can have every variable only written once. So we want to make sure we take care of that. So I recommend here combining what you can. So this is being multiplied. So we have 3 times negative 4, which is negative 12. Then I would look at x to the second times x to the second. Remember, when you multiply, you add. So 2 plus 2 is 4. Then I have y to the second times y to the fourth. So being multiplied, 2 plus 4 is 6. Okay. One thing I want to point out, negative 12 is to the first power, so all my powers are positive, so my final answer is negative 12, x to the fourth, y to the sixth. Example 2. Everything is being multiplied here, so let's go ahead and write it out. So I have an a to the negative third, a to the second. Negative 3 plus 2 is negative 1. B, I'm not being multiplied, so I have b to the fourth, and I have c to the negative 1. This is not properly simplified because I have negative exponents, so the way I take care of those is, remember, move them to the denominator. So my b to the fourth will stay in my numerator, and my denominator I would have a to the first and c to the first. Typically don't write to the first power though. So there is example 2. Example 3. We have p to the third over p to the eighth. Biggest thing to remember here is that always bring the smaller to the larger and subtract. So I'm going to take the 3 down to the 8. So it's 1 over p to the 8 minus 3. So I have 1 over p to the fifth. Okay, there's example 3. 4. Let's go ahead and look at it. First, look at my numbers. 15 divided by negative 3 gives me negative 5. Now I look at my c's. Always bring the smaller to the larger. So I would have 5 minus 2, so I have c to the third. Oh, there's more than one c, so maybe let's, so I took care of these two c's. I'm going to rewrite the c to the seventh down here. And then d to the third. Let's simplify. Not all my c's are together, so I still have negative 5. My c's, bring the smaller to the larger, so it's going to be in the denominator. 7 minus 3 is 4, so c to the fourth. And then I would have d to the third. So my final answer is negative 5, d to the third, c to the fourth. Got a few more examples with simplifying exponents. Number 5. So I notice everything in here is being multiplied, so that means I can give everything to the fifth power. So I would have negative 2 to the fifth, p to the 3 times 5 is 15, and r to the 10th. Okay, now negative 2 to the fifth. You would type that in on your calculator, make sure you put parentheses, negative 2 to the fifth, and when you do that on your calculator, you should get a negative 32. Okay, so that gives us that our final answer is negative 32, p to the 15th, r to the 10th. And number 6, same thing here. We can give each piece the negative 3. So I have a to the negative third over 4 to the negative third. We do not want to have negative exponents, so we swap them. So we're going to have 4 to the third in the numerator and a to the third in the denominator. 4 to the third is 4 times 4 times 4. You can type it in on your calculator, but it's going to give you 64 over a to the third. So this is the end of the part of the notes on simplifying exponents or properties of exponents. If you have any questions, please write them down. Otherwise, we're going to move on to scientific notation. The forms that we usually write numbers in is called standard notation. Okay. A number in scientific form is in the form a times 10 to the nth, okay, where a is in between 1 and 10. Really, it just means that a is only one digit. And by that I mean it has one number and then a decimal point. There can only be one number, okay? And then a decimal point, and then you can have more decimals, okay? So you always have, it's in between 1 and 10, okay? So you could have 1, 2, 3, 4, 5, 6, 7, 8, and 9. You cannot have 10. It can't be equal to 10 because then it would be 2 digits. So that's scientific notation. So let's just go ahead and look at some examples. Okay, the density of an object in grams per milliliters is found by dividing the mass of the substance by the volume. So we have density equals mass over volume. A sample of platinum has a mass of 8.4 times 10 to the negative second kilograms and a volume of 4 times 10 to the negative 6 cubic meters. Use this information to calculate the density. Okay, so the density is equal to our mass, 8.4 times 10 to the negative second, over our volume, 4 times 10 to the negative sixth. Okay, so what we're going to do is we're going to simplify this. Very similar to how we just did it. So we have two numbers. What is 8.4 divided by 4? You can do that on your calculator, which gives you 2.1. Times 10 to the, okay, I have these two. Bring the smaller, which is negative 6, to a larger and subtract. So we'd have negative 2 minus a negative 6, so it's really plus. So I have 2.1 times 10 to the negative 2 plus 6 is 4. So my final answer is 2.1 times 10 to the fourth, and we are talking about density. Well, mass is in kilograms and volumes in cubic meters. So it's really kilograms per cubic meters. Okay, so there is my answer. These two numbers, though, these are written in scientific notation. Just to talk about this one really briefly, if you had 84 times 10 to the negative 1, that's not proper scientific notation. I would have to move it over one more. So make sure that it's only one number and then a decimal, okay, to make it proper scientific notation. Okay. Example 8. After the sun, the next closest star to Earth is Alpha Centauri C, which is about 4 times 10 to the 16th meters away. It says, how long does it take light from Alpha to reach Earth? All right, so we're talking about how long does it take that to reach Earth. So that is talking about time. Okay, we have an equation, distance equals rate times time. Okay, so let's just write down what we have. We have distance, rate times time. What do I know? I want to figure out time. I don't know time. Do I know my rate? Well, they're talking about the light, so it travels at 3 times 10 to the 8th meters per second. So it's 3 times 10 to the 8th. And do I know my distance? Yes, 4 times 10 to the 16th meters away. So I know everything but time. So I'm just going to take this equation and solve it for time. Time is really equal to the distance divided by the rate. Okay, so my distance away is 4 times 10 to the 16th over my rate, 3 times 10 to the 8th. If we take 4 divided by 3, we get 1.3 repeating times 10 to the, now I simplify when I divide, I subtract 16 minus 8, gives you 8. So 1.3 times 10 to the 8th. Distance, okay, and we're talking about in time, so these are meters and seconds, so we're talking about in seconds. 1.3 repeating times 10 to the 8th seconds. That's how long it will take to reach Earth. Number 9 also uses the fact that light travels at a speed of 3 times 10 to the 8th meters per second. The average distance from Earth to the Moon is about 3.84 times 10 to the 18th meters. How long, so time again, would it take a radio signal traveling at the speed of light to cover that distance? So once again, we want to know how long. So distance equals rate times time. If I'm solving for time, I know that time is equal to distance over the rate. The distance I need to cover is 3.84 times 10 to the 8th over my rate, which is 3 times 10 to the 8th. So the time is 3.84 divided by 3, which is 1.28 times 10 to the 8 minus 8 is 0. Remember, anything to the 0 power is 1. 1.28 times 1 is 1.28, and this is labeled in seconds. So the radio signal can cover that distance in 1.28 seconds, so from the Moon to the Earth. All right, that will be it for Unit 7, Video 1. If you have any questions, please let me know. Otherwise, have a great day, and I will talk to you later.